Hi everyone, this is Anushka and welcome back to my channel A in Economist. So in the previous few videos we have seen how to construct frequency distribution of continuous variable, discrete variable as well as for attributes, and we have seen how to present that in a tabular fashion. Now it's time for us to go into the diagrammatic representation of frequency distribution. So we'll see what are the kinds of diagram that we can use in order to represent the frequency distribution of various data types. So let's start. Before going into the video, I wanted to share with you my educational qualifications. If you are interested to know me, you can take a look at this. Okay, now let me straight away go into the topic. For attributes, if you talk about attributes or the qualitative variables, then let's see what are the diagrams that you can use. You can use bar diagram with horizontal bars, and I have also covered these diagrams in a separate video. If you haven't seen the video, I will give the link in the description. You can check that out, that we can use the bar diagram with horizontal bars for exhibiting frequency distribution of attributes with absolute frequency. So when you have the attributes on one side and their corresponding frequencies on the other side, you can use the horizontal bar diagram that I will show you in a while. And the second thing is that we can use divided bar diagram or pie diagram for exhibiting frequency distribution of attributes with relative frequency, and I have also showed you how to calculate the relative frequency. It is just the frequency of a particular attribute divided by the total frequency, right? This is how you calculate the relative frequency, and for expressing attributes corresponding to their relative frequency, you can use either divided bar diagrams or you can use the pie diagram. Now let us see this with the help of the example. This is the table that we have constructed in our previous videos. So it is showing the sex of infants born in a city hospital. If you haven't watched my video, again you must see that before going into this video. So there we have seen the gender and the number of births corresponding to that, and these are for attributes. Let's see how we can visually depict that. So for that, as I have mentioned, you need to use horizontal bar diagram. So here on the vertical axis you are representing the gender or the sex of the newborn child. It can be either male or it can be female, and on the horizontal axis you are representing the number of births, and you are drawing horizontal bars for each of these attributes, right? For male you have 22 newborn male child, so this is the horizontal bar diagram, and for female you have 18 female child born in April 2024. So this is how you can represent the frequency table that you have constructed, right? Now what happens if you are taking the relative frequency? If you are taking the relative frequency instead of absolute one, for example here, what will be the relative frequency? It will be 18 divided by 40, and this will be 22 divided by 40. So if you want to depict that in your diagram, you can use a divided bar chart. We also call it subdivided bar chart. So you are taking into account only one vertical bar, and you are then dividing that vertical bar into two segments depending on the relative frequency. So here from this diagram what you can see is that the male relative frequency is higher than the female, right? So if you see numerically, this is 22 by 40 and this is 18 by 40. So in this way, so the proportion of the male child born in the city hospital is more than the proportion of female child born in the relative sense, and that is the importance of representing this into a diagram, right? So from the table itself you may not comprehend the entire meaning of it, but if you draw this in a chart, in a diagram like this, then it becomes visually more appealing and it becomes very insightful for your further statistical analysis. Again, what you can do, you can also use a pie chart. If you have the relative frequency, I have also taught you in a lecture how to construct pie chart, so you can do that also using relative frequency, you can also construct the pie chart. So you'll see that female population is 45% approximately, and the male percentage is 55% in the total births, live births of babies in the city hospital. So with this we have covered the diagrams that we use for attributes. We have seen the bar diagrams, we have seen subdivided bar diagrams as well as pie diagrams. Now let us consider the case of discrete variable. Again, I am taking the example that you have done on your own. For the discrete variable case, frequency distribution of the family size, we have constructed this in our previous videos. So let's see what are the diagrams that you can use to depict that. First diagram is the column diagram. Column diagram, also known as the frequency bar diagram. Here what you do, for each family size, so on the horizontal axis you are plotting the family size. So you have to write these numbers on this horizontal axis, and you are simply writing frequency on the vertical axis. From the table you have this frequencies corresponding to these family sizes, and you simply need to plot it. So for 2 you have the frequency to be 9, for 3 you have the frequency to be 20, and like this you are plotting the frequencies for each of the family size like this. And then simply what you are doing, you are drawing a line segment, you are joining this with a line segment, and this will be your column. So this column does not have any width, it is just a visual depiction in this way, right? For 3 corresponding to 3 you are drawing joining this line segment, and this will give you your column for the particular family size of 3, and you are doing this for each of these family sizes, right? So these are the straight line columns from the origin, and this will visually depict the frequency distribution of family size. What you can also do is that you can draw a frequency polygon. It is nothing, it can be constructed from this column diagram only. So instead of vertically joining this with a line segment, what you are doing, you are just joining this with a line segment, right? You are manually joining this. I am not using any ruler, so it's not straight lines, but when you will be doing on your copy, join it with a straight line. So this is how you construct a frequency polygon. You are just joining these points using a line segment. And sometimes what we do, we want to use a closed graph, so we join this with the origin or join it with the previous value. So here you have to, so suppose you are plotting 1 somewhere, and just join it, and with the 0 frequency, the frequency has to be 0, join it here and also join it here. Suppose this is 8, so join it here. So if you want to have a closed graph, you can also do that, otherwise this depiction is also fine. Now we have also seen how to calculate cumulative frequency. Now what happens if you, instead of frequency, you are plotting cumulative frequency on the vertical axis for the discrete variable, then you get a step diagram, which is also known as cumulative frequency diagram. So this is the process is almost the same. You have to plot family size here. All you need to do, plot cumulative frequency here, and if you do that, you will see that how many families are there with less than equals to 2 frequency. It's 0, so the graph starts from here. Now how many families are there with less than 3? For that you are adding the frequencies of 2 and 3, so you will get this particular line segment. How many families have 3? Sorry, so you will get this line segment basically. If you see the chart, okay, let me go to the chart. So how many families have less than equals to 3 frequency? It will be 20 plus 9, so you will get 29, and the plot will be here. Sorry for that. For 3 you have to go here, the plot is here, so you have to join this with a line segment. For 4, what will be the value? For 4 you have to add this 59, right? This is 59, and here you are plotting that for 4 this is 59. So from 3 to 4 you don't have anything, so you write this, and then from 4 you are joining this line segment. So if you do this, you will get a step like diagram. It is literally called the step diagram. So these are the 3 diagrams that you can use for your discrete variable case. For absolute frequencies, you can use column diagram or frequency polygon, and for cumulative frequency, you can use the step diagram. Now let us see the continuous variable case. For continuous variable, you have to use the class boundaries, right? You have to plot the class boundaries and their corresponding frequencies. Let's see what are the diagrams. Again, you can use the frequency polygon. Now you are taking the interval, say the interval is from 30.5 to 40.5, but when you are plotting it, you are taking the middle value. So 30.5 to 40.5, you have this interval. You are considering something called the class mark. You are plotting something called the class mark, which is just the average or the middle value of this, which is 35. So corresponding to 35, you are plotting this frequency 6. Again, here you will have the class mark to be 45. Corresponding to 45, you will plot 14. So do that. 35, you have 6. Then you have 45. For 45, you will plot the value. For 55, you will plot the value. For 65, plot the value. 75, plot the value, and just join them with a line segment, and this will give you your frequency polygon. And the most important and mostly used diagram for depiction of continuous variable is histogram, something called histogram. Here the horizontal axis is the same, you are just plotting the class boundaries, but on the vertical axis you are plotting frequency density. What is frequency density? It is simply the class frequency divided by the class width. It is class frequency divided by the class width. So instead of plotting class frequency or the relative frequency, you are plotting the frequency density. So you have to calculate frequency density for each of the class interval, and for each interval you need to draw a separate separate bar. And the difference of this histogram from the bar diagram is that you don't have any gap in between. So bars can be plotted using equidistant, maintaining the distance, equal distance, right? But in histogram case, there is no gap in between. You are depicting the class boundaries without any gap here. So you need to see how the frequency is distributed over this class boundaries without any gap in between. And also another interesting thing here is that, so here we seen that on the vertical axis you have frequency density, so class frequency divided by the class width, and on the horizontal axis you have the only class width. So what will be the area of this? What will be the area? Area is length into breadth, so do that. So vertically you have this and horizontally you have this. So if you see, this is the frequency. So the area, if you see the area of each bar, it will give you the class frequency of this particular class, right? This is another important thing to note, that it will give you the class frequency, the area of each histogram. Each vertical bar will give you the corresponding class frequency. This is what is histogram. And finally we have something called the ogive. Ogive is again cumulative frequency. It's a representation of continuous variable frequency distribution in terms of cumulative frequency. Here one thing you have to note, you can do this for this is the less than type, this is the less than type cumulative frequency, and this is the greater than type cumulative frequency. And how to construct this? For that, what you have to do, for less than type of cumulative frequency curve or ogive, you need to take the upper boundary. You need to take the upper boundary and its corresponding frequency. Take upper boundary and its corresponding frequency for each of these cases, right? For each of these cases, this is the process, and that is how we have got this particular curve. So upper boundary and its corresponding frequency, upper boundary and its corresponding frequency, and you are just joining it by a straight line. And for the greater than type, do the reverse, take the lower boundary and the corresponding greater than type frequency, right? For the less than type, you need to take the upper class boundary, and for the greater than type, you have to take the lower class boundary, and this will give you your ogive. And later on we will see that the intersection of this ogive will give you the median. This will give you the median value, and we will see this when we will discuss the central tendency. and this is what I want to show you. Thank you for your time, and if you like this video, give me a thumbs up and subscribe to my channel. Thank you.